So, in order to now derive the wave equation, which we said we will do, what we need to do is, there are 3 steps basically. One is, as we said, somebody moved something, so gas particle moved for whatever reason, and because of which that means movement, sorry, caused change in density. Okay, because if you remember the people in a party situation, the movement changed the density because a lot of people again got stuck there. So that there was a change in density, in the normal density. And as soon as there is a change in density, so this delta in rho will cause a change in pressure. Okay, so as soon as the density changes, pressure will change, natural, and it's with respect to our people in a party thing. As soon as they come closer, they get tensed. Okay, immediately the feeling. So that's the increase in pressure, and then the change in pressure causes movement, because the people, when they panicked, they moved forward, and that thing actually caused the next movement, and this cycle goes on. Okay, and that is how we in fact see the sound wave moving. Okay, now we will just write these 3 statements mathematically, and that will give us the wave equation. It is as simple as that. And somehow we will start not at this first one, we will start with this second one. Okay, now it's very natural that pressure, you can think of some function of density. We don't have to now we don't have to think what function this pressure is of density. Some function, it will be a continuous function of density, and if we change, and then suppose we think about the condition where when even the table was not moved, or that means the sound wave had not reached. Okay, so that place, so that means if we say that it was P naught is equal to F of rho naught, right? So the same function, so the equilibrium density is rho naught, the equilibrium pressure is P naught. But then as soon as the table moved or the sound wave reached a particular point, your P naught now has become some P excess has come into picture, and that F rho naught, also rho plus rho excess, has come into picture. Okay, but then this we can write as F of rho naught plus what, rho excess times a df by d rho at rho naught, and neglecting the higher order terms. I just expanded this in Taylor's expansion, and we are neglecting this because everything is small. The change in density, change in pressure, we are talking about micropascals. In fact, the micropascals which I was talking about, this is this excess pressure. Okay, so this is 1 lakh apple, this is one piece of 1 lakh cut of an apple. Okay, now, so that means, yeah, so this is gone, right, because this is that. So we have your excess pressure is rho excess, and so this I will now write, you know, you can say dp over d rho sort of thing, isn't it, at the point when at the equilibrium condition. This f is nothing but the p only, whatever. You can write f also, doesn't matter. That means, so simply we can say that it's some constant, suppose, we can say constant rho e. That means the change in pressure is proportional to change in density with some constant. So that is our first relationship, or second relationship in fact, where this constant is how the pressure changes with respect to density. Okay. Then what? Let's go to this first one. Now, for the first one, let's say we are talking about, say, a plane which was at x. Okay, let's say this is the green plane. You think that all those molecules were colored green, they were at x. And similarly consider another set of particles which were at this location, which was x plus dx. Okay, so and then they were blue particles. Now as the wave passed through them, the disturbance, so they moved certain distances and let the green one move, be moved to this one. Okay, so this one in a way psi at x, and the other one, I needed longer length of the tube. Okay, say it moved here, suppose, and this distance was psi of x plus dx, right? So that means whatever mass of gas was there in this zone now is, suppose the area is 1 unit of this tube or something which we are looking at, that is 1 unit area. So that means rho times, so initial thing was rho naught dx was the mass which was entrapped here, right? And now it has become, the mass won't change, because as we said in the beginning that we are talking about plane waves, so there is no mixing of colored molecules, so no interaction, no turbulence. So anything which was there is still now entrapped within this zone, right? So that means now it is like x plus dx minus this times rho naught plus rho e. Right? So just the mass balance. Now what happens? So multiply them. Okay, this can be again or okay. Something is yeah. So that means this is like, you know, d xi of dx times dx, right? This term. The change in xi times this, because the definition of this is this by del x, okay? And yeah, I mean dx I could have written, whatever, okay. And this one is rho naught plus rho e. But you see here, this rho e is small and this also is small, okay. So this will be a second order term. So we just have, we can neglect that because we are neglecting all the second order terms. So this will be in a way what? Something I'm missing somewhere. But I'm not getting can you point out where I'm missing something? Where?
In that psi x plus dx minus.
This one, right? Yep. Because, yeah. So there I made a mistake. Because see, I should have done like, shall I do like that? Okay. So this should be corrected to, see, it's like you have x plus dx plus that, right? Right? Minus x plus whatever xi x. That should have been the thing. Yep. That gives you this, right? Because yeah, x plus this, yeah. Then what extra term are we getting? In this, I think we will be getting one more. A dx term, right? So that means this will be like, is it fine now? Okay. Or did I miss it? Somewhere still something is missing? Let's see. So that means if we divide now with dx, what shall we get? This is d xi over dx times rho naught plus rho e plus rho naught plus rho e, right? Fine. I just divided del x, so that makes this plus 1. Yeah, that's fine. Then what are we getting? Let's expand this. So this rho naught gets cancelled here, and so can I squeeze it in here? This rho e times this is second order, so this rho e should be what? Negative of this. right? Is that fine? This rho e times this is second order, got neglected. So this rho naught times d xi over dx comes here as negative, and this is the excess. Yeah. So what does it tell you? That means if the displacement xi is changing in the x direction, then there is a reduction in density. That means suppose you have, there were rows of students sitting like that. If every row moved proportion to their location, because if every row moves exactly the same amount, the density won't change, obvious. But suppose the first row goes by 1 distance, second by 2 distance, third by 3 distance, like that, then we see that the density is changing. That is what this term is telling. And if the displacement is increasing as we move in the positive direction, then the density decreases. So that is why this negative. And this rho naught is telling that it will also be proportion to the initial density. Whatever is initially available, it will be proportion to that. Okay, so that's what this tells you, that the change in, so what was our, so movement changes density. So this is the relationship, movement changes density. And what about the third one? Okay. Now third one again, if we see here, if we consider that x and x plus dx planes which we were talking about, one was whatever green, the other one was blue, like that. Now here suppose the pressure was P at x, and here the pressure was P at x plus dx. And if you see, the pressure were acting like that, like this, right, on that zone. So what is the total amount of pressure which is acting in the positive x direction? It's say P at x minus P at x minus x plus dx. So that's the pressure, and area is unity, so this itself is the force also, and that should be equal to, and then so that should be equal to what? The acceleration of that mass which is entrapped, right? So it's the rho naught times dx is the mass, its acceleration. Right? And this is nothing but your dp over dx. Fine. So that means something is missing, a minus sign, right? Because this is the opposite way the differentiation definition is. So fine. So that means you are saying that now rho naught del square xi by dt square is negative of this one. Right? That means in sentence, what do you say? that if there is a decrease in pressure, if you look forward in the positive x direction, if there is a decrease in pressure, then there will be a forward force acting. If it is an increasing thing, then it will be a backward force. Okay, and yeah, so this is just the Newton's law of motion. So we have now all the three things, right? So that is one, so we have all the things. So let me take this thing. PE is some constant times. So our excess pressure is some constant times rho E. Then we had this one, rho E, rho E is negative of rho naught this, and the last one which we got is this, rho naught d fine. So what you do now is you just suppose substitute this here. What would you get? Because that will just eliminate our P, and you will get negative K d by dx, right? And then you substitute this here, and you will get what? Minus K, minus becomes plus with this minus, rho naught square xi square. Right? So this rho naught gets cancelled, and you get del square psi by del t square is equal to that constant x squared. Right? So, and if you remember, this constant was nothing but how pressure changes with respect to density. So if you increase the density, obviously the pressure will change, or the other way around also you can think of, if you increase the pressure, the density will also increase. So it will always be a positive quantity, right? Pressure's relationship with density will always be a positive. So you remember we, and in the string case, we had got there T over rho or something, and both were always positive, so we replaced with c square also. So here also it can be replaced with c square, which will give you in fact the speed of sound wave. Okay. Okay. So we will stop here for this segment, and we will again meet in the next segment to discuss further.